Hi everyone, David Blakey here. The name of this video is Python Regular Expressions Quantifiers. Now so far, let's just do a quick review of what we've seen before. We've seen just regular pattern matching, like ABC. We've seen the anchors, like anchoring to the start, ABC. We've seen strings that anchor to the end, ABC and then $. And then we've seen the character classes. So we could say, let's say the digit class, 2 digits followed by a period followed by 2 more digits. This would match on a floating point number that begins with 2 digits. But let's say this would match on something like this. And in fact, we could put a $sign in front of it to make it into like a price. Notice that we backslash the $sign there as we backslash the period. The reason we backslash both of those is because in regular expressions, those characters have their own meanings. They have meanings within regular expressions. Of course, you know that the $sign means anchored to the end of the string. And the dot actually is a special class of its own. It's a character that'll match on anything. We haven't talked about that yet. We're going to talk about that in the next couple of videos. But that's why we have backslashes there. Of course, you can see we're backslashing the D because we want to indicate the digit character class. So this regular expression, and this is not regular Python code, right? This is just the string representing the pattern. Would match on a dollar amount like 13.45. Of course, if we were going to be trying to match on something like, let's say, a dollar amount, but we didn't know how big it was, it could be $1.45, it could be $13.45, it could be $130.45, or anything in between, then we'd want to be able to use a quantifier to say something like one or more. For instance, we might expect that, and this would be in the realm of validation again. If we asked somebody to type in a dollar amount, let's say without the $sign, if we asked them to type in a dollar amount, we'd want that dollar amount to match a pattern that we're familiar with. In other words, it should be able to match on all of the following: 13.45, 1.45, 113.45, or 99. Or 1113.99. We won't worry about the commas at the moment, but if we ask the user to type in a dollar amount and it didn't match one of these patterns, we'd know that there was a problem. But so far, we haven't seen how many, how to specify that there could be one or more of a digit character. And that's what we would want to do in the above. This particular pattern only matches on a 2-digit number. So how do we say one or more? Well, we use a special quantifier. It's called a quantifier because it'll quantify what you want, and it applies directly to whatever's before it. So in this case, it's applying to the digit character or the digit character class at the start of this string. \D plus. So one or more digits followed by a period followed by 2 digits. And we might go so far as to anchor them. But we'll do that later. So now this particular string, pattern string, that is a string that is a regular expression pattern, will match on any of 13.45, 1.45, 113.99, 1113.99. Now I've obliterated it, and I'm not sure if I'm gonna. Well, it would be easy enough to recreate, but I don't have my test program in front of me. I just have the strings. But we can do this easily enough. We'll say if. We'll say, why don't we say once again, pattern equals, and we'll make it this. I think you're more important than any call that I might get. And let's say the test string equals, well, we'll just make it one of these. In fact, we could go so far, and this might be an interesting thing for you to do, is to make a list out of your test strings so that you can test a number of things at once. And you may remember from the homework that we did this. Take a look. All right, let's take a look. Let's see. Okay, we're putting this into a list. And now we'll say for string, for Meister in test strings, if re.search pattern and Meister print matches, and I'll use quotes again. And this will be followed by the pattern and the string. So let's check that out. And let me open this up. Yeah. Okay, let's see how we do with that. Test.py. Okay, matches in all of them. Matches in all of them. Now, let's screw it up. Let me ask you this. What if we did that? You see the 113.99999. Would that match? Here's another one of your quizzes. So remember some of the things we talked about in previous videos and ask yourself whether this would match. Here's a hint. Don't jump to a conclusion that seems obvious to you. Take another good hard look and remember the two things that we said before about regular expression matches to keep in mind. Okay, have you got it yet? Let's find out. Looks like it matched. It looks like 113.99999 matched. And why? Why? We clearly specified one or more digits followed by a period followed by 2 digits. So the question is, do you see that here? Well, I see one or more digits followed by a period followed by 2 digits. Why, yes, sir, I do see that. I do see that. We didn't anchor the match. Right? So the pattern will match anywhere in the string if it needs to. You know, we could go on and you know, screw this up this way, and then put in another dot and another number here, and that'll match. Why will it match? Well, not because this is a number, which it clearly isn't, but because we have at least one number here and we have 2 numbers here. So one or more numbers followed by a period followed by 2 numbers. We're in like Flynn, as they say. Now, if we wanted to take more control, which we often do, we would just put a caret here and a $sign here, and now the match has been anchored, and the bad boy won't show up. Yes, only ones that make sense now match, because for sanity's sake, we put in anchors. So good. That's the idea of a quantifier. Now we have 3 quantifiers that we'd like to look at, and then the custom quantifier. The first is the one I mentioned before. It's the plus sign. Here I'm gonna put comments here. Plus sign means 1 or more. Next one, the star, which means 0 or more. And the third one, the question mark, which means 0 or 1. Now these quantifiers are used all the time. The last one I'll show you is the custom quantifier, where we can specify the upper and lower bound between 2 and 4. You can say custom between 2 and 4. And any of these quantifiers can be applied to any other thing for it to work. So we could do something much simpler. We could say, let's apply our quantifier to the A, and say 1 or more A's followed by, let's say, 0 or more B's followed by between 1 and 3 C's. Let's take a simple example like that and ask ourselves what's going to match. Now I'm going to do each one of these, and it would be great if you were to ask yourselves for each one whether it'll match. Okay, now remember again, oh, and I'll throw one else in there, one other one in there just to, okay. Let's do another one. Can't get enough of these. It's like a drug. Let's do A, C, B. Okay. What are some of the things that we have talked about as far as kind of the things to keep in mind with these? There were two major things. One was that matches are on consecutive characters. And the other one was that matches are on substrings, i.e. will match on any portion of a string. Okay? So let's look at these, and knowing what the pattern is, what does this pattern say? Let's look at this pattern closely. It says 1 or more A's, followed by 0 or more B's, followed by between 1 and 3 C's. That's what we're looking for. 1 or more A's, followed by 0 or more B's, followed by between 1 and 3 C's. Now I've got a couple of gotchas in here. What would benefit you the most is if you stop this video and take a good hard look at these and be logical and ask yourselves whether you see this. And once again, take the point of view of the regular expression engine, which says, I'm looking for an A. Okay, did I find an A? Yeah. Did I find 1 or more A's? Yeah. Did I find 0 more B's? Yeah. Did I find, oh, I'm already giving you the answer to one. It goes character by character looking for the next part of the match. And if it doesn't find it, it's going to keep going. It'll keep going looking for the match to occur somewhere within the string. So let's take a good hard look at this. Take a break if you wish, and see if you can make all this work. Don't be passive. Don't be passive. You're always being so passive. Take a good hard look. Ask yourself whether it's working or not. You want to be able to get this because there's a couple of gotchas here. The first is a gotcha that we just discussed earlier in the video. Second gotcha has to do with 0 or more. Realize what 0 or more actually means. 0 or more means that it might not be there, and it may be there in force. The third thing, remember that matches are on consecutive characters. Okay? So take a look on your own, and then when you come back after you unpause, we'll look over it. Okay, great, we're back. I personally just looked to the side for about 10 seconds, or about a second and a half, and then went again. But you pressed pause, didn't you? And I know you did. And take a good hard look at these. Let's look at these. Remember, we're looking at between, well, 1 or more A's. So we can begin with that. 1 or more A's. Well, we did find 1 or more A's. Next thing to follow 1 or more A's is 0 or more B's. 0 or more B's. Well, I don't see a B here, but there doesn't need to be one. So that also matches. And then between 1 and 3 C's. Well, there's 2 C's here, so that matches. So it looks like it matches on the whole string, and that will definitely match. Second one, let's see, maybe it would be better to just run it to prove that I'm correct, and also so I don't embarrass myself. I guess we've got to save it. But the other thing that we need to do is let's see. Okay, so for this second string, we'll take a person who doesn't know perfect English. This pattern, no match. No match. See? You see how I can make a joke about poor English without getting into the issue of ethnicity at all. That no match. That no match. I'm not saying this is anyone. Really. I'm actually saying it's me when I'm really tired. No match. That no match. Okay. 1 or more A's followed by 0 or more B's followed by between 1 and 3 C's. So what do we got here? Again, 1 or more A's followed by 0 or more B's, yeah, followed by between 1 and 3 C's. Excellent. 1 or more A's followed by 0 or more B's followed by between 1 and 3 C's. Well, this is a gotcha. Did you say that this didn't match? Did you say it didn't match because there are 4 C's? Remember, we don't have any anchors on this. So it did match, but it only matched up to here. 1 or more A's followed by 0 or more B's, of which there were 3, followed by between 1 and 3 C's. And since quantifiers will take up as many characters as it can, it does match on all 3 of those C's. But the 4th C just doesn't match. That doesn't mean that the whole thing doesn't match. Remember, patterns match on any portion of a string. So they're consecutive, and they'll match on substrings. So it doesn't need to be the complete match. If we needed it to be the complete match, we would use anchors. Okay, next one. 1 or more A's followed by 0 or more B's followed by between 1 and 3 C's. Well, there was no A here, so no match. No match. That no match. How about ABC? Well, it does match. Why? Because there's 1 or more A's followed by 0 or more B's, of which we found 1, followed by 1 to 3 C's. Yes. How about this one? Well, we have an A and a B and a C. That should match. There's 1 or more A's and 0 or more B's, of which we found 1, and 1 or more C's. But they're not consecutive. They're not consecutive. They're not consecutive. How could we make something like that match? Well, quite easily. If we wanted to say that there might be an X after the A, and there might be an X after the B, and there might be an X after the C, it would be quite easy. Let's come back to that in a minute. A, B, C, 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 C. This matches. Why? It's 1 or more A's followed by 0 or more B's, of which we found 1, followed by between 1 and 3 C's. This is me trying to catch you again. I didn't realize it was caught before. But this matches because we do have all of those things, and we didn't anchor the match. Last one, A followed by some C's, followed by some B's. This was meant to trip you up into thinking, oh, wait, the B's are in the wrong place, so this doesn't match. Well, it does match, and the reason it does is we have 1 or more A's followed by 0 or more B's, of which we found 0, followed by between 1 and 3 C's. So it actually will match on this. Again, it doesn't, since we didn't anchor it, it doesn't care what else is in the string. It's designed not to care. It's designed, I've been programmed not to care, doctor. Okay, forgive my weird jokes. What, again, going back to this one, what if we wanted to follow the A with a possible X, the B with a possible X, the C with a possible X? We do it quite easily. Remember, we have a third quantifier, or I should say a fourth quantifier that we haven't looked at yet. And that's the optional 0 or 1 quantifier. So here, just so that it gets really crazy, we're inserting a possible X. It's not going to disturb any of the other matches that have occurred. If it matched before, it'll match again. I know that off the face because these X's are optional. They might be there and they might not. So that means that any of the matches that occurred or that were valid before are going to be valid still because we made these optional. However, it will allow our new string that we love so much with the X's to match. Let's see. So now it matches AX, BX, CX. Terrific. So that's quantifiers. Quantifiers will apply to anything that's immediately preceding it. And as you can see, it allows us to account for things that might be there 1 or more, or that might be there not at all, or in force, or might be just 0 or 1 worth. It also allows us to specify how many we want. Some things I want you to try to avoid, if you can, is to not have a custom quantifier that actually could be better served or equally served by a regular quantifier. Here's the one or more quantifier, and it's told as a custom, between 1 and however many. If you leave off the upper bound of a custom quantifier, it allows for up to as many as you like. In other words, this is one or more, and we shouldn't see one or more here if what we really mean is plus, which is the same thing. You ought to use the built-in where you can. People are more familiar with it. We can also, by the way, if we wanted to say 3 or 3, between 3 and 3, in other words, looking for 3 C's, specify the same upper and lower bound. We'd even go so far as to say 3. Now what I don't want you to see is 1, between 1 and 1. Which quantifier do you suppose this can replace? Well, none that we've seen. It replaces just really, it would be the exact same thing if it were not there at all. Just take it away. Now all of a sudden it's a C, meaning just C by itself. That is 1C. So don't ever do that either. Just say between 1 and 1. Well, that's what the presence of it within the pattern means anyway. All right, to look at a couple of one other example, just to show you something a little more practical. What if we wanted to be able to match on user IDs from NYU? This is an example I have in the handout, and also one that I talk about in class incessantly. It should be able to match on any of these. And notice the variations. All right, I think that's good enough. So what have we got here? And let's throw in maybe a couple of others to try to confound you. Great, there's one too. Okay, take a look. Let's come up with a pattern that's going to match on these. Well, aside from the last one, which is designed to try to fail if possible, we do have a kind of a pattern that we can cognate on, as it were, and follow. It's between 2 and 3 letters followed by 1 or more numbers. So all the first 5 of these strings should succeed. And the last one should probably fail. But all the others should succeed. How can we create, oh, and why don't we put in a couple of other dummies here. We'll just put in hello, and we'll just put in a number like 1, 2, 3, 4. How can we make it so that the first 5 succeed and the last 3 fail? I'm going to put in a pattern that expresses this. First thing we want, of course, is between 2 and 3 letters. So how do we do that? Well, we could say between 2 and 3 word characters, but actually, as you know, word characters also cover numbers and the underscore, and we definitely don't want that. So we're going to use the letters character class. For now, we'll just say lowercase a to z, because we're just going to assume that it's lowercase. Lowercase a to z followed by 2, 3. Now remember what I said about a quantifier applying to whatever's directly before it. In this case, it's not a single character. It's the a to z character class, which is really a single entity within regular expressions. So it's not going to apply to the brace, because the brace is really part of a larger entity. Same thing we did with, let's say, \db plus. When we said \db plus, or d rather, \d plus, we weren't referring to 1 or more d characters, right? We're referring to 1 or more digit characters. So in that same way, the a to z is really a single entity, and we're now following it by a 2 to 3 quantifier, which says between 2 and 3 letters. That's basically what it's saying. Now we want to be able to say between 1 and more, somewhere 1 or more digit characters. Let's do that. 1 or more digit characters. Okay, great. Now there's something else that's missing, and I want you to pick it out. So I want you to stop the tape and ask yourself whether it's doing exactly what we want it to do, which is we want the first 5 test strings to succeed, and we want the last 3 to fail. And ask yourself whether that's going to happen or not. Pause it and come back. Okay, we're back. Maybe you didn't pause it. Maybe I'm asking you to pause it and you didn't actually pause it, which would mean that you're secretly and quietly rebelling against my authority, my authorita. And I'm really, I'm hurt. I'm hurt if that's what you're doing. Let's take a look. Let's see. This pattern, 2 to 3 letters and 1 or more digits, matches DBB2 and 2. Good. Matches MM64. Yes. Matches. Okay. Matches, matches, matches. Okay. Doesn't match hello. Doesn't match 1, 2, 3, 4. But does match this crazy nutty string. And why does this crazy nutty string match? Because look at the beginning of it. DBB24. In fact, it matches once with DBB24. And then later it matches again. ABCDEFJ143. Of course, it's only going to match once. It's not designed, we haven't asked it to match more than one. But look, there's a match as well. What is missing from this? The anchors. The anchors, of course. The anchors must anchor the string if we're going to validate it. So we're going to put an anchor at the beginning. We'll put an anchor at the end. And now it's going to hopefully do what we want it to do. No match, no match, no match. That's exactly what we wanted. Okay, awesome. So that's quantifiers, and I hope you enjoyed them. Let me know if you have any questions, and please give me feedback on these videos.